Tulshi Shiyani, and my topic is solar photoelectrochemical energy conversion. Next, so this work mainly to convert solar energy for generating electricity as well as solar fuel. So generally, what we are using today, it's most of inorganic materials. So I have tried to combine organic as well as inorganic material to increase the absorption of solar spectrum, because most of solar spectrum is wasted and we are not able to use whole spectrum. So that's my main objective and motivation. Next. So this is a solar energy received on the earth by various countries and by various areas. So each country and each area are getting solar energy at different intensities. Next. So these are mainly three technologies to harvest the solar energy. First is a photovoltaic cell. The second is a photosynthetic, artificial photosynthetic process, because in nature, more trees are are converting solar energy for their food into chemical energy. And third one is a concentrated thermal solar power. Next. So these are the hybrid solar cells. So in hybrid solar cells, we are combining organic as well as inorganic materials. So there are four types of nanomaterial: 0D, 1D, 2D, 3D. So in first in this figure A, that shows the dye plus quantum dot, and in figure B, it's a thin film with nanowire, nanorod with organic protein complex. And third, that shows the thin film and layer by layer, inorganic and on that hybrid. So it's a layer, thin film solar cell, hybrid thin film solar cell, hybrid quantum dot solar cell, hybrid that nanostructure based solar cells, and third one is 3D particles. Next. So this is a main principle of photoelectrochemical cell. So in photoelectrochemical cell, what we have to give some voltage to splitting the water. So that voltage comes from the photovoltaic cell. So we are using solar energy to split the water for oxygen, for generating oxygen and hydrogen. So this oxygen can be released in an atmosphere, and hydrogen can be used for our purpose, our application. Next. So what we have done, we have first fabricated ZNO oxide thin films. On that, using a spin coating method, we have used ZNO using spin coating method. On that, we have deposited basil organic dye. Basil is a traditional plant that we can see in our homes also. So that contains mainly chlorophyll as well as quinine. So we can absorb the visible light as well as UV light. So that hybrid structures I have used for this work. In three electrode system I have used to make a device, photoelectrochemical device. Next. So this is XRD that shows the high quality ZNO film. Next. And this is morphology. So we have fabricated ZNO thin film using about 500 nanometer thickness, and the crystallinity is good. Next. This is a absorption property. So we can see that in absorption as well as band gap. So we have calculated the band gap also. So we can see the visible as well as visible at for basil it's a 675 nanometer. For ZNO is a 349 nanometer wavelength absorption peak. Next. So we have calculated the parameters, PC device parameters, photoelectrochemical conversion. For ZNO, we are getting efficiency about 0.02, and for hybrid device we are getting 0.7% efficiency. This is a low efficiency, but because these are all devices are laboratory scale, so my motive is to increase this efficiency and we can use it for indoor application. So we can convert the various light what we are getting in our house or home for solar electricity as well as power, and we are getting higher efficiency. It's more about 33% higher than the basic device. Next. So this is conclusion. So uh, mainly we have studied and investigated the photoelectrochemical properties of a hybrid device, and that we have achieved a higher performance compared to basic device. And this study will be helpful to study the hybrid devices for solar electricity as well as solar fuel conversion. Next. And this is next. And these are the references. I already have published many papers on that, and I'm thankful to CIF as well as our collaborator and Institute CSRDAE for the utilization of various fabrication and characterization facilities. Then next. Thank you.